My name is Dylan Dixon.
I'm Garrett Moore.
And today we'll be performing the Jack Frost in a glass experiment. So this experiment will focus on the sublimation properties of benzoic acid. So because we're using an acid like this, we must have an apron, gloves, and goggles on. So for this experiment, we'll use 5 grams of benzoic acid. This acid will be placed into a 1 liter beaker. Following that, we'll use copper wire and attach that to a small branch of plant like so. And after that, the branch will be placed into the beaker with the acid. Then we'll take the beaker and everything inside of it and place it onto a ring stand with a gauze pad between. And then we'll place all of that into there, rig up a Bunsen burner, and then just use a match to light the burner. So this experiment poses many threats, which is obviously why we need goggles, gloves, and an apron. Benzoic acid is caustic and irritable to skin, so if it touches your skin, it can actually leave a burning sensation. But more importantly, the sublimation process can pose even more threats. When it begins to sublime, it will give off a white gas at a very rapid rate. If this gas is inhaled, it can cause severe respiratory discomfort. If the gas gets into your eyes, it can cause permanent eye damage, which is why this experiment must be performed within the fume hood. The fume hood will keep all of the gas inside of it, and therefore it can never have a chance to get out.
And the globally harmonized system for chemical hazard classification is very applicable for this experiment. Basically what this does, it lets people understand the dangers of the chemicals they might be handling in an experiment. Obviously benzoic acid falls under that category. The GHS is split into 3 major hazard groups: physical hazards, health hazards, and environmental hazards. Benzoic acid is mostly a health hazard, as you can see by this graph here. I'm sure everyone's seen that on just basically any toxic chemicals. You have health hazards, fire hazards, reactivity. This helps show it a little bit. Health comes in at a 2 out of 4, which is by far the highest for anything else we have here, because it has the eye irritants, the skin irritants, and it can damage your respiratory tract if it gets into your system. So it's very important just to kind of be aware of what you're dealing with. So reference the GHS for this experiment.
So now we'll actually set up our experiment. So take our branch and place it standing upright.
We'll use the match to get it lit so we can get it to sublime. Alright, so we have a pre-made experiment right here, so we don't have to sit here and wait for it to begin to sublime, because that'll be a process that'll take a little bit too much time. So you'll see some of the results that are going to come through. Once this begins to sublime, it'll create what's called a hoarfrost, and during that period it'll be really hard to see within here because it looks like a foggy cloud almost. So what you're going to look for during this period is when you're going to try and see if there's no more solid on the bottom of the beaker, because that means the sublimation process has completed. So and that means you're going to want to turn off the burner at that point so it can return back to its normal solid state. And then once that happens, you'll see that it starts to cover up the stick right here. You can see it kind of looks like a snow or a frost, which, you know, Jack Frost. The reason this happens is because obviously if it's subliming, it's skipping from the liquid state, it's going right from solid to a gas. So it's floating around inside the beaker, and what it's going to do when the burner turns off, it's going to return back to its normal solid state, and it's going to attach itself basically to the first thing it touches, which in this case will be the stick, because it's the most upright thing within the beaker.
So for benzoic acid, this sublimation process occurs at about 100 degrees Celsius according to the Center of Disease Control and Prevention. The melting point of benzoic acid is 122 degrees Celsius, so it's important not to overheat the acid or else it will just become a liquid. So as Garrett said, once the sublimation process is complete, you turn off the burner, and then the gaseous benzoic acid will turn back into a solid and cover the stick. So for real world applications, one example would be frost-free freezers. These freezers accelerate the sublimation process by using a fan and air circulation within the freezer. This keeps the ice off the walls and shelves while the ice cubes continue to sublimate.
Another part of the theory, which you can see starting to happen right now, is a physical change is taking place. You can tell it's a physical change because it's in a gaseous state now. It's not a chemical change because it's still benzoic acid in its form. It just looks different now. If it were a chemical change, the atoms in it would be rearranged and we'd be dealing with something that isn't benzoic acid anymore. And obviously the physical change starts to take place once it turns into the fog cloud. And another real-world application which you can see is actually bathroom air fresheners. I found an article called Sublimation Examples in Everyday Life, and it tells you that the solid air fresheners that you can sometimes see like strapped to the side of toilets, that's a form of sublimation because it's taking the solid gel that's within the packaging and slowly turning into a gas over time to release a pleasant smell within the bathroom as opposed to what a bathroom would normally smell like. So it's very beneficial for everyone there for that form of sublimation. As you can see, it's a slow process, but it's taking place right now. So, are there any questions for us?